So this video will be for total area, and I'm going to do it based on our knowledge from 5.2, where I kind of introduced you to total area. So displacement is our net signed area. And really that's our wording for our just plain old integral. Total distance will be the sum of all the areas where all negative integrals are added as a positive area. So using integrals, which is easier? Obviously displacement, because displacement is a simple one integral. Okay? The net signed area is one simple integral from A to B. The total distance will be the sum of multiple integrals. Okay? So let me put that here. Sum of multiple integrals. And why are there multiple? Because it'll be based upon our x-intercepts. So looking at the problem that I have, this is a visual problem where if I asked you for the displacement, or if I asked you for the net signed area over our interval, and our interval goes from -5 to 18, it would look like this. -5 to 18 of the function. And the net signed area, if I asked you to actually calculate it based on the values I gave you, it'd be +10 minus 30 plus 1 minus 20. And so that's -50, -40, -39. So that would be the net signed area. But if I asked you to find the actual total area, we would have to find multiple integrals. We'd have to go from -5 until 1. So that would be this piece here. And that would be of f of x dx. And then the next piece I'm going to do would be this piece here, which is negative. So what I'm going to do is negate a negative, which will make the value become positive. So that would go from 1 until 10. And then I'm going to take this little piece here, which would be a positive area because it's above. Therefore, I put a plus. And then, very last piece would be this piece until 18. And that would look like this because it was underneath the x-axis, which means the integral value would be negative. I need to make the integral positive, so I subtract the negative. So what would that look like in terms of an actual answer? And let's go back in colors. So the blue area is +10. It would stay +10. The pink area is minus -30. The purple area is a +1. And then the orange area is a -20. So I subtract the -20. So what actually happens is for each of these, this would become a plus, and this one would become a plus. So what do we have? We have 41 plus 20, so that'd be 61. So that's the total area of the graph. So now I'm going to do an actual problem. I don't think it was too difficult. Let's see how I made it. So t squared minus 6t plus 8, where t is in seconds and v of t is in meters, and we're going to find the total distance traveled from 0 until 2. So what I'm going to actually do first is the displacement from 0 to 2 seconds. So what does that look like? The displacement would be the integral of the velocity. And how do we know that? We could use our units to figure that out. And that would give me the displacement, how much I've moved from where I started to where I ended. And it doesn't matter what type of movement I did in between. Just looking at a picture from where I started and a picture from where I ended, it's how much I moved during that time. And actually, let me change this because I purposely did this problem So let's go till 6, which will make our numbers a little bit larger. So the displacement from 0 to 6, okay? Which means I would need to find an antiderivative. So add 1 to the power, divide by 3, minus 6t, add 1 to the power, divide by 2, plus 8t. And I'm going to actually simplify this so that I can calculate a little bit better. And then plus 8t. So I'm going to need to find f of 6. And I'm going to get a little bit of help here. So 6 cubed divided by, let's see. So what am I looking at? I'm looking at 6 cubed, which is 216, divided by 3. And then I'm going to subtract 3 times 36. And I'm going to add 8 times 6. And that's just so that I don't make any kinds of mistakes. So f of 6 is 12. F of 0 would be 0. So I'm going to come back up to the top and write in that f of 6 minus f of 0 would get me my displacement. The answer would be 12 minus 0. So the answer would be 12 meters. Is how much I moved. The change in distance, and I want you to use the word change in distance, from time equal to 0 to time equal to 6. So it doesn't matter if I ran a whole marathon, but then came back to 12 meters ahead of where I started. The displacement ends up being 12 full meters, okay? The other thing I actually want to do is I will end up showing you the graph at one point. So let me get that set up now. So that's t squared minus 6t plus 8. And then my window, negative time does not work for us, and we're only going to 6. And my y values, I'm going to assume negative 10 to 20. And we'll see if that's enough. Right. So now I'm going to actually do the same exact problem as a total distance traveled, which is different. It's a completely different question. So moving over, I'm going to paste that in. So I am going to find the total distance. So the total distance by hand, the first step would be find my x-intercepts. Because usually I've been giving you a graph, and the first thing we need to do is divide the intervals. So I'm going to take t squared minus 6t plus 8, set it equal to 0. I did make it factorable. So t equals 4 and 2. All right, so here's what we're going to do. 0, we're going to make a sign chart. 4, and then where I end is going to be at 6. So the interval was from 0 to 6. And what we're going to do, we're just going to graph a sign chart for v of t. So not a derivative. I did not take a derivative. I'm just doing the sign chart for the original function. And really, it's a parabola facing up. So here's what the graph has to look like, because there are the two zeros. Otherwise, you would have to put in your values into here to see if they're positive or negative. So there are my signs. So what that tells me already is that to find the total area, so step 2 was a sign chart of original function. Okay. Step 3 is your integral statement. Using x-intercept intervals. And your sign chart pretty much gives you this. And what I mean by that is that the total area would be the integral from 0 to 2 with this plus sign here, would mean that the integral has to be positive. Then I'm going to subtract away my negative area, which would be from 2 to 4. And then I'm going to add in my positive area from 4 to 6. So this will actually give us the total area. So really what I would do is find the antiderivative, which we did in the last problem. It was t cubed over 3 minus 3t squared plus 8t. I'm actually going to do this problem in the calculator just to remind you how to do it. So what I'm going to do is set up in my y equals the original function, and I'm just going to do all the integrals. So what does that look like? I'm going to do math. Number 9 gives me fn int of vars. Oh, that's not the button. Vars. Move over to y vars. Enter. Enter. Comma. X. Comma. 0. Comma. 2. And I'm going to do them piece by piece. And let's actually turn that into a fraction. So the first blue integral is 20/3. The pink integral. And if you do this right, your pink integral should be a negative number. So if I go from 2 until 4 and press enter, I get a negative value because my sign chart told me it was going to be negative, and that's minus negative 4/3. And then in orange, I'm going to do my last integral. So, and that would be from 4 until 6. And then I'll also show you what the graph looks like to kind of put it all together. That's 20/3 also. So really, I'm going to add that. So I have 44/3 is my total area, which is bigger than what I had before. 44/3 is 14.66666, so 14.66666. 3 decimal places. I put the line there for you so you know it keeps going, but that's obviously bigger than the answer I got before, which was 12. The area was bigger in the second problem. Now, what I'm going to do is double check this answer just to make sure I didn't make any mistakes. I'm going to do the integral, and I get back to it, from 0 to 6. And hopefully my 12 is correct. There we go. All right. Then the other thing I wanted to do was graph it for you and take a look at the graph. So obviously my window is a little bit off, so let me change that to -5 to 10. There we go. That's a little bit better. So let me actually get back to the page I was on and go one more further. Let's take that and analyze it. So I am going to take a picture of it when I get to it. I can do this. And let's take that. There we go. So this is actually the velocity function, v of t, from 0 until 6. This is obviously 2. This is obviously 4. And what we just found was, if I was to look at the total area, I took that red piece, subtracted my blue piece because it's negative, and then took this pink piece and added them all up. But the integral from 0 to 6 is the net signed area. So it's what becomes of adding the actual areas together. What that means is that negative piece in blue will end up really being subtracted away from the positive area. So kind of like if you have money and you owe money, your net would be how much money you have left after you give the money to the other person. The owed money goes away. So that's what the net does. So I think that's a good representation. The last thing I wanted to show you was a kind of cheap way on the calculator to do total distance, because I noticed a lot of my students don't use the calculator properly. So if you're lucky enough to watch this video, which you all should be, you will then know how to do this. So here's the graph of the function again. And we don't need a graph to do this, which is the greatest thing about using the calculator. What total area does is really, it takes this graph in pink, it wants to find this area. So it doesn't want the area in the middle to be negative. If you flip that over and shade it, that would actually give you the total area. So what you should recognize just happened, the pink graph, is actually the absolute value of v of t. So when you're doing this in the calculator, you don't need, so by calculator, let's be very clear about this, in the calculator, no need to find x-intercepts. How do you do this? You do f and int of the absolute value of the function, comma, x, comma, from where to where? 0 to 6. So what did I really do? I took the function, I did 0 to 6, absolute value of the velocity, and then took that and did the integral of it. Notice the absolute value bars are inside the integral, not outside the integral. So I want to graph the absolute value function first, which is now free graphed in purple. And then I want to take the area of that. So the total area in my calculator will look like this. I'm going to go to math, number 9. Absolute values is, I believe, hidden under math, number, and then I'm going to press vars, y1, comma, oh no, sorry, close my parentheses, then comma, x, comma, 0, comma, 6, parenthesis, and press enter. And you should get exactly what we had before, 14.66666666, which is equal to the 44/3. Why don't I show you this from the beginning? Because the majority of your total distance problems you'll have to do by hand. But if you get the chance to have a calculator, obviously knowing this is going to be extremely helpful. It cuts down a lot of work. So again, by calculator, you don't need to find x-intercepts. You're just going to take the absolute value of the function you're trying to take the average value, the total area of. So we're going to reflect the negative pieces up above the x-axis. Then we're going to integrate, which means to take the area, the net signed area, but what you'll notice, there's no more negative area. We only have positive area. So that should cover the last topic in 5.3. I hope you can understand the video. Please remember, stop and rewind if you need to. That's the beauty of having a video and not having me live, because you can't really stop and rewind me each time. All right, have fun, kids. Make sure your homework's done by Monday. Thanks.